Every time you take a shower or flush a toilet, you start an invisible journey beneath your feet.
The water that disappears down your drain will travel miles before it ever returns to the natural world. Hidden under every street is an enormous network of pipes designed to carry away wastewater.
It's called the sewage system, and it's one of the most important and least seen inventions in human history. Without it, cities would be uninhabitable. Diseases would spread and rivers would be poisoned. Today, we decode how the sewage system beneath every city works, from drain to river. The journey begins in your home's drain pipes, which drop vertically to a smaller pipe called a sewer lateral. That lateral connects your house to the main sewer line running under the street outside your front door. These pipes are buried deep enough to avoid freezing and damage, carefully placed below the frost line. As wastewater leaves your home, it joins flow from your neighbors, converging into ever larger pipes along the way. A major city can have thousands of miles of sewer lines, enough to wrap around the entire Earth. And remarkably, the entire network operates mostly by one simple force: gravity. Sewers are laid with a precise downward slope, so that wastewater keeps moving without getting stuck. If the slope is too flat, solids settle and cause blockages. If it's too steep, the liquid rushes away and leaves solids behind. The perfect slope keeps a self-cleaning velocity, about 2 feet per second, so the flow carries everything along. Engineers use topographic maps to route sewers through natural valleys, making the best use of gravity and reducing digging. In many older cities, stormwater and sewage share the same pipes in what's called a combined sewer system. During very heavy rain, overflow structures release excess water into rivers to prevent the system from flooding streets. But gravity can only do so much. In flat areas, or when pipes need to go uphill, pumping stations take over. A lift station collects wastewater in a deep underground well, then uses powerful pumps to push it up to a higher sewer. These centrifugal pumps can lift millions of gallons every single day, moving the flow over hills and across the city. A central control system keeps an eye on pump status, flow rates, and alarms around the clock to keep everything running. A series of lift stations can move wastewater across an entire city, step by step, overcoming any hill or ridge. Regular maintenance and inspection make sure the pumps are always ready for the next surge of wastewater. After traveling through all those pipes and pumps, the wastewater finally arrives at the treatment plant. The first stop is screening. Bar screens catch large objects that should never have been flushed, like wipes, rags, and plastic. Next, the water slows down in a grit chamber, where sand, gravel, and other heavy particles settle to the bottom. In the primary clarifier, a large circular tank, the water slows even more. Heavy solids sink as sludge, while by now, about 60% of solids have been removed. But dissolved organic waste is still in the water. That's where biology comes in. The next stage uses billions of helpful microorganisms to clean the water naturally. The screenings collected from the bar screens are washed and sent to landfill. Those items were never meant to be flushed. The sludge from the primary clarifier is thickened and then pumped into sealed tanks called anaerobic digesters. Inside the digesters, bacteria that thrive without oxygen break down the sludge, producing methane gas as a byproduct. That methane can be captured and used to generate electricity or heat, helping power the treatment plant itself. After digestion, the leftover material is dewatered in a centrifuge, turning it into a dry, soil-like substance called biosolids. Those biosolids are rich in nutrients and can be recycled as fertilizer for farms and forests, turning waste into a valuable resource. Back in the main treatment line, the water enters aeration basins, where air is bubbled through it to feed those hungry microorganisms. The microbes, billions of bacteria and protozoa, form an activated sludge that consumes the dissolved organic pollution. After several hours, the water flows into a secondary clarifier. Here the microbes settle out as sludge, leaving clear water above. That clear water is then disinfected, often with ultraviolet light or a small amount of chlorine, to kill any remaining harmful organisms. The final treated effluent is so clean, it can be safely released into rivers and streams without harming fish or wildlife. And so the water cycle continues. Downstream, that same water may eventually be drawn into a drinking water plant and returned to your tap. The sewage system is a silent, hidden machine that protects public health every minute of every day. It works around the clock, preventing waterborne diseases that once devastated entire cities before modern sanitation existed. At Source Code Daily, we uncover the invisible infrastructure that keeps our world running. Subscribe to see more deep dives. If you value understanding how the invisible world works, hit subscribe and turn on notifications. New episodes come out every single week, exploring the hidden systems behind modern life. Thanks for watching. Keep decoding the source code behind modern civilization.